Welcome back, everybody. This is your fourth video, and the quiz will come along with it. This will be the last quiz that you do that goes along with one of our videos. I hear a lot of you guys are having a great time with these videos. What? You don't like them? I guess I better bring back the second camera. And maybe turn the music up? Oh, down? You want the music down? All right. Well, today we're going to discuss the project report in a little bit more specific detail. We're going to look at the document. We are going to readdress the concepts of audience, purpose, the standards of excellence in technical documentation, including honesty, clarity, accessibility, comprehensiveness, professional appearance, usability, accuracy, conciseness, correctness, and most importantly, honesty. Honesty is the principle that's so nice, you gotta say it twice. Speaking of professional appearances. And of course, we're gonna talk about ethics. All right, so let's get started. Let's read this together, shall we? This is the final report guidelines and format recommendation. By the way, in regards to the quiz that I'll be making for this video, I am going to use some very specific details from the sample report and also from this document. They're actually available, so all you have to do is go to the course shell, and you can feel free to use the documents as you take the quiz. I'm going to use some very specific details from the document because I think it's very important that we sit through the entire thing once and analyze it together. This format guideline has been made in such a way to hopefully introduce you to why this document even exists. And while we're not going to ask you to talk about why your document exists, it should probably make itself clear. I just realized that I forgot to turn on my very special background here. Let's get that going. All right. Final report guidelines and format recommendation. This document shows the order in which your text should appear and the topics it should address. Additionally, it shows the order in which your presentation slides will appear in the final presentation. The final report delivers a lot of information in a single document. Implementing the items below will ensure the necessary components while telling the story of your project's inception, creation, and testing phases. Implementing this order is probably the simplest thing you can do. So what I want you to try to do is incept why these different aspects of the project are important based on these ideas of clarity, honesty, accessibility, and ethics, among the other standards of excellence. Project title. This is a cover page with team information, liaison advisor information, and a table of contents. Now, not to get too deep into it, but it only makes sense to give credit where credit's due. That's where team information comes in handy, and your liaison advisor. They're also a part of why your project is what it is and why it's as good as it is. So they also should receive credit for that. And the table of contents, that's a way to address the reader. Obviously, the table of contents is going to make it accessible. Your document probably should not be read necessarily like a book. People should be able to look for what they need out of the document without having to go from beginning to end. For example, somebody might just want to see the data, and so the table of contents is going to make that viable for them. Some people may just be interested in the introduction, so you'll be able to guide them there. Now let's go to the introduction. What's in the introduction? Customer, sponsor. Oh, okay, so there's like a potential customer involved in this. background of the problem, the needs, requirements, and a solution. So this is to just talk about whatever problem your computer program addresses and what the needs of the solution are. We'll talk more about that later. The background, challenges, or limitations of existing solutions. Right, so addressing the previous bullet point, when we talk about what is needed to happen in the solution, that's probably because there are some limitations in the solutions that have already been created to address this problem. That would give your motivation behind your proposed solution. You're going to make the solution better. And somebody probably has addressed this problem before, so we're going to see what sets yours apart from it. And then finally, the unique achievements of your project. No matter how your project turned out, it attempted to apply a different solution to a problem that existed. And so even just attempting to address that, whether or not it actually does a better job of addressing it than previous solutions, it at least shows the limitations of a new process, of your process that you chose. And somebody can decide from there whether or not they need to elaborate on your solution, or if in fact that solution is kind of a dead end or something like that. We want to know, what did the individual members contribute? Again, this is an ethical consideration. People should be given credit for what they have done so that other people don't accidentally get credit for it. Somebody looking at this report should need somebody like a particular individual in your group to help them with a future project, so you want them to stand out. How does your project stand out from previous solutions? Again, you're discussing what sets your project apart as an academic pursuit. It even can have purpose in failure, so don't worry about that. As an academic pursuit, a project could even have value in the ways that it failed to improve on previous solutions, because its own motivation, its own desire to fix previous problems, make it stand out. What are the key design principles? Again, these are reasons that your project stands out from previous solutions. You've got your own design principles in your project that are hopefully going to differentiate it from solutions that have come before. What are the benefits of your design? Question mark. And finally, what are the experiment testing results? Now, in a way, here's something different that people don't always know when it comes to project reports until they do them, that you kind of get the whole beginning, middle, and end in the introduction. You should be able to tell just by reading the introduction how the program went overall, how your project went overall. And the sections that come next go into greater detail for those more technically minded people. But the introduction, sometimes there's something called an abstract or an executive summary that goes along with the introduction, so that somebody with the more executive power in the company can make a decision about whether or not to implement your design, and we'll ask somebody more technically minded to look through the details of your project in order to decide how viable it is, so or how to implement it. And keep thinking about that executive. Keep thinking about those business partners that need to be a part of this process, because that's how we're also going to design our writing projects. So stay tuned for that. I'm going to be releasing a video next week about the writing project. Part 3, related works and technologies. This is the background where you go into detail about the existing solutions. Review any existing works that attempt to solve the same problem. Describe why you chose the techniques that you used for implementation, and justify your process. So this was a very analytical moment for you, and it might have felt very natural to you and your group to make the decisions that you made. You might have felt like you were just using intuition or common sense, or just doing the obvious thing by coming up with a solution. But it's not going to be obvious why you came up with your solution to somebody just reading your report. So after having discussed the issues with previous solutions to your problem and discussing why that you're doing something different, discuss why you think the things that you're doing different are justified. Number 4, system architecture. Now you're going to get into the details of what you did. And this is going to be specialist information. Describe the system architecture, include the DFD graph. Chart signal workflow or the data exchange flow between different software components. Software, algorithm, system development, and implementation. In this category, please describe the implementation steps and details. Describe the algorithms implemented. I would like to know more about that. I personally have never implemented an algorithm, so hopefully somebody comes to my office and shows me exactly what they did. Results and conclusions. Describe results include interesting findings. Those interesting findings can become a project that somebody looks into in the future. What succeeded? What failed? Discuss any follow-up research and development required to successfully implement your program. Number 6, references. Use proper formatting when writing and editing your references section. When it comes to that, that's an ethical issue as well. You just want to give credit where credit is due. Make sure that all the professionals and the academics and the workers that came before you get credit for their work. And you want to use proper formatting to make it more accessible, to make it so that these works that came before you can be easily found. Are you going to implement this in an excellent way? Here would be the standards of excellence for this report. Excellent implementation of these features will reveal a narrative of discovery immediately apparent to those with CS specialization. So anybody in your field, they should be able to follow your report like a story. And even the system architecture part, that's where they're going to see things that maybe other people reading your report won't see. However, at the same time, with effort, readers of other disciplines will be able to decipher your process, and they should also be convinced of the soundness of your approach. Even if they're not CES majors, they can determine that your process is sound because of the way that you described all existing works that attempted to solve the same problem, and the fact that you justified your own process. They should be able to understand that your process was sound. You might be able to fake them out with the data, but anyways, it should appear to be basically an airtight process with the human element of discovery and analysis, basically. Your group's honesty with data and the integrity of your process becomes apparent to anybody in your final report. All right, now let's go to the sample report here. Now this is going to be a slog, and I wish I had somebody here to read it with me. This is the kind of thing where I would ask somebody in my class to help me out. But we're working remotely here, so I'm just going to have to do it by myself. Oof. It's not going to be the best this way because I'm going to become boring. So part of a good technical document is that it offers variety. You don't get bored. You just get to what you need. And unfortunately, this is just me. and my boring voice going through an entire project. Please do your best to stay critical. I'm going to also insert some discussion points here, but it is just going to be my voice, and so try not to fall asleep. All right, let's go. Senior Design Funnel Report, Augmented Reality for Hydrology, version 1.0. And this was turned in back in 2018. It was considered an excellent version of the report, which is why we're offering it as an example of how to use it. Here are the team members who came before. Godspeed to you. They're probably working for some company from home. Not really, just like you're experiencing some interesting times, they're probably experiencing some interesting times at their jobs. Here were their liaisons. Faculty advisor, Dr. Elaine Kang. Great. So you know that if this is an excellent report, everybody here deserves at least a little bit of the credit. They did make some executive choices, like they talked about the future. You know, that's a nice little section to put in, and it wasn't really in the guidelines, but it makes sense that it would be in there. All right. Actually, let's look at this a little bit more closely. Introduction, background, design principles, design benefits and achievements. Great. Related technologies. So related technologies is related to background, I think. Existing solutions, reused products. I don't know what that means in the context of this. I think we will find out. This might not be an appropriate section for your essay. I mean, your report. System architecture, there's the overview, data flow, and then implementation. Finally, we get to conclusions, where they discuss the results, hopefully in an ethically sound way, where none of the data was fudged or smoothed over, and nicely they add a future section. Now, why are there question marks here? I'm not really sure. This could have been an issue with the PDF conversion or something like that. Or maybe they actually did forget to do this, but even though they might have forgotten to put these page numbers in here, it's not really a question of where they are, because, I mean, there's just, I don't know, is there really only 6 pages though? No, there's a lot more. There's 12 pages. You know, it actually looks like maybe these page numbers are wrong. So you're going to have to forgive them for that. Somebody forgave them for that, because it's still up here in the example, a prime example. It must be that everything else went so swimmingly that was forgiven by the reader. All right, introduction. 1.1, background. NASA's Jet Propulsion Laboratory, JPL, is world famous for their work in space exploration. JPL also does a lot of work in Earth science. One example, JPL's WaterTrek database. WaterTrek contains a vast amount of data on hydrological features such as wells, reservoirs, rivers, etc. But currently, this data is readable only by scientists. By visualizing this data in a more meaningful, such as with augmented reality AR techniques, this vast amount of information may be more approachable to the general public. Therefore, JPL has teamed up with California State University, Los Angeles to develop an AR application to showcase WaterTrek data. In addition, a development framework will be provided for other developers to use. The framework is designed for general purpose AR, meaning that the same techniques and libraries can be applied to other scientific data, not limited to just hydrology. What is augmented reality? In short, augmented reality allows projecting information onto the real world. One way to do this is with a mobile device, such as a smartphone. When somebody points their smartphone at the world, the camera can display the real world onto the device's screen. Then, images, 3D objects, and text can be drawn on top of the camera image. This makes it appear as if the images, 3D objects, and text are actually in the real world, augmenting what the user sees. The augmented reality app and framework are both initially developed for Android devices, with the plan to expand to other frameworks such as iOS or DJI drones at a later time. Well, looks like, yeah, this project is already showing its age. The iOS already has augmented reality now. Just ask my Pikachu. Looking at what this is all about, this is a nice background. I don't know how AR is really going to help us to visualize this data. But I don't know. We'll find out. 1.2, design principles. The framework is the main deliverable, and the app uses the framework in order to showcase the functionalities of the framework by visualizing hydrology data from WaterTrek. The goal is to make the framework general purpose, meaning it should not be dependent of WaterTrek or any specific data workflow. In addition, since the framework may be used by software developers who may not be familiar with computer graphics techniques, it needs to provide some interfaces that abstract computer graphics and still provide what the developer needs. The app to showcase the framework needs to be simple, intuitive, and it needs to not make excessive calls to the WaterTrek database so that the app does not hog the database's traffic. Also, since WaterTrek is still currently under development, the app needs to be simple in design so that future maintenance and expansions will not be too complicated. Okay, interesting. So we see that all this data needs to be pulled from the database, but they don't want to plug up the database with people looking for new sets of information all the time. So I'm guessing they're trying to figure out how much information to preload or something like that. Visualizing hydrology data. Okay. I don't know why you would need to visualize data on like a, it makes me wonder, is there like a map and they're gonna point their camera at the map and then the map, and then when they look at the map through their phone, it's going to show like the water information or something? Not really sure. And one thing I will note is that we did see some grammar errors. They were easy enough to correct, and they were easy enough to make, because these are the kind of grammar errors where if you don't read it out loud, you can easily skip over the missing word or correct it in your brain. We are always doing that, and that's not a good thing necessarily. So far, it doesn't seem like there's anything dangerous about the way that the data or that the sentences have been a little bit broken up, but I did have to use like a little bit more brain energy than what I've liked to kind of piece together the sentences. You want to save the brain energy of the people who are reading your document. So as much as you can, don't waste their brains on fixing your grammar. 1.3, design and benefits. By having an architecture that allows the framework to expand with the demands of the developer, we essentially ensure its usefulness for future augmented reality visualization projects. The framework aims to provide facilities and developers of all levels of expertise so it can reach a broader audience, and their demands will drive its success in the market. The framework provides a simple interface that can be used easily by developers without OpenGL knowledge, while allowing additional features and components to be added by developers that do have that knowledge. The app, on the other hand, is designed with simplicity in mind. Since the framework does the bulk of the work necessary to set up augmented reality visualization, the app just has to concentrate on retrieving data from the WaterTrek database, providing local storage, and providing a nice user interface. In this way, we keep the app simple and scalable, and this allows it to improve along with the WaterTrek database, which is still under active development. 1.4, achievements. Over the course of the academic year, our team has been able to develop a preliminary framework that provides augmented reality visualization of simple primitives. such as billboards and 3D geometric objects. The framework is currently built and hosted via a Maven repository, so any changes, revisions to the framework does not require any changes, revisions to the implementation at all, and the implementations only need to be rebuilt to reflect these changes. An app that utilizes the framework has also been successfully developed, and it can currently retrieve and visualize wells, reservoirs, and soil moisture data from WaterTrek. The architecture for the app has been kept as simple as possible, and we have successfully decoupled most augmented reality visualization components from the app. So the framework is solely responsible for how augmented reality visualization appears, and the app simply has to retrieve data. The framework takes care of user permissions, sensors, camera, and 3D computer graphics for the app. There are still facilities in the framework that allow for more in-depth customization of the augmented reality visualization provided, and so the framework may now scale from super simple projects all the way to very complicated projects that are heavily coupled with the framework. I see. So going back to what they said before about not putting too much stress on the data itself to be, or their project to be completely responsible for the visualization, while the app just has to retrieve data, I'm assuming numbers, and then just the numbers themselves will determine what the app does in its visualizations. Seems like a smart move, but I think it would be even crazier if they tried it a different way. I don't know. I guess we'll find out if in existing solutions there was an issue with that before. Let's take a look. We have looked into some existing frameworks for creating augmented reality visualization applications. These include Apple's ArcKit, Google's ArcCore, and Vuforia. While these solutions do allow us to reach our goal with this project, they come with certain restrictions and limitations. Apple's ArcKit is specific to Apple's iOS platform, and it is only available on version 11 of the operating system, with further restrictions on the different devices that can access this framework. So ArcKit does not work for us if our intention is to reach a bigger audience. Google's ArcCore is in beta form, and it is very constrained in terms of performance. A very powerful Android device is necessary in order to run ArcCore at reasonable performance. Furthermore, ArcCore is only available on Android version 8 and upward, and again, much like Apple's ArcKit, it is limited to only a few devices. Vuforia is reliable and proven multi-platform AR framework. However, we decided against using it initially because of their approach to AR, as discussed in the next paragraph, and because there's a licensing cost. The main approach of the AR frameworks mentioned above is to use computer vision techniques to recognize features in an image, such as the image from a smartphone's camera. When the device moves, the movement of the feature on the screen can be detected. This allows the AR framework to render objects in the correct place on the screen, even as the device is moving. I hope you've all experienced a little AR. It's quite fun, and yeah, it was pretty mind-blowing when I first saw it. This approach works well at detecting motion, but suffers when the registered features are not within sight. For example, far away or obstructed by walls, trees, or other objects. Also, while computer vision has come a long way at recognizing that a picture contains a building or mountain, these techniques have a hard time quickly identifying which building or mountain. Right, so one of the issues they have is that, so they actually want to be able to tell perhaps which mountain they're looking at through their camera, because perhaps different mountains have different water information or something like that. And maybe they actually also do want to use far away objects, which may be obstructed by things all the time as you walk around and move around. Since our AR framework is meant for representing distant specific objects, there it is, we need to use a different approach. Instead, we are using GPS location and rotation of the device along with the coordinates of the object to be tracked to determine the proper place to draw objects on the screen. We did not find existing frameworks that provided this functionality and thus were required to write our own. Wow, now that sounds like a lot of work. Just to kind of maybe critique this a little bit, I don't know if you feel like you understand exactly what this project is, but I think it would have been nice if they had just at some point said that they are trying to make a product that would make it so that you can point at distant objects and learn meaningful information about hydrological features. So it took a while for us to get there. And remember, that's for them. They're going to think, obviously, this is what we're doing because they've been doing it all year. So see if you can step outside of yourself a little bit. And remember that some people are absolute 100% noobs at your project. They have no idea what you were up to. But wow, we're going to see that they have to build their own framework. Interesting. Number 2.2, both the application and AR frameworks are developed in Java using the Android SDK. The Android SDK provides facilities such as sensor access, UI elements, camera access, network access, and OpenGL drawing routines. SQLite database management system is used for local storage for various operations on data, such as filtering search results. You know, even without a background in CES, I can kind of get a sense of how these products are working together just based on their small descriptions of what they're doing. Page 5. Okay, so supposedly we're on the second to last page, according to this table of contents. I guess it's not 100% clear whether or not these are page numbers or not. All right, let's go ahead and check out the system architecture. 3.1 overview. 3.1 overview. The architecture for both the framework and the app is the same and can be broken down into three main factors: the user, software developer, the framework, RLib, and the Android system. Here's a diagram, DFD level 0, that shows how this architecture works at a high level. And here we have a beautiful image, and they give credit to the person who came up with the image here, Bill Pham. You notice, though, before we had some errors in the sentences, but if we started having errors here, things could easily get out of hand. Just an extra letter in this or the wrong letter in this, and suddenly you're talking about possibly a different product or a different acronym. And here we can kind of see how the graphics are probably the best way to describe how the information is transmitted on this program. Okay, the user developer. This is the that image in there. The factor in the arc considerations need to be made on how the framework will be used. To that end, one of the members, Christopher Hung Wen, acts as the user for the project, and his work on the app embodies this factor. Whatever the user requires in order to implement his app is exactly the base functionalities that we have to provide in the framework. This is the main goal of the project. The framework provides functionalities that the user can utilize to implement their app. Also, the framework acts as an intermediary between the user and the Android system to abstract and take care of many of the setup procedures that the user would otherwise have to do by themselves. For instance, the framework automatically takes care of setting up permissions, motion sensor data, camera, and OpenGL ES rendering. So the user does not have to go through the trouble of doing that. The Android system. Through the use of Android SDK, many interfaces are available that allow for more convenient access to hardware features that are available on the device. For example, Android provides an orientation sensor, a mixture of the accelerometer, magnetometer, and gyroscope depending on how the system is set up. This is potentially different depending on the hardware of the device. So this sensor can be used directly without us having to implement our own code to do about the same thing. Now I noticed something as I was reading this previous sentence, OpenGL ES. Do I know particularly what that is? No. But I do remember seeing that the ES on the previous iteration of it was not capitalized, and then here we see that it does get capitalized elsewhere. If I had seen this repeated, I would have thought, okay, this is accurate. You never capitalize OpenGL ES. But the fact that I saw it capitalized later makes me say, hey, and come back here, and this is why I was confused. OpenGL is drawing routines, because it was already in this other list, and it kind of looks like an error, as if maybe there's OpenGL and drawing routines or something like that. So consistency is important because it can be confusing. Also, I just want to point out Bill Pham. Let's see if he was in our group here. No. Okay, so Bill Pham, unless Kwong is Bill, in which case probably should have normalized that too so that he can take credit for the image that he created. Those are some of the things that I can like catch for you if you come by and have me read your paper, but other people can obviously do that too. People in your group can obviously do that. Tough thing about getting somebody in your group to do it is that people in your group might be working with something more technical and not really want to do the editing work that it takes to make a super clean doc. So anyways, I'm available to you, but so is the Writing Center at Cal State LA. Maybe I'll put a link for them right here. So are other people who you know in your life, who maybe you can help them with something in their homework, and they can help you with something. But you don't, if you don't have the time, just go to the Writing Center and come to my office. 3.2, data flow. Here's an overview of the framework as a system and how it connects to the app implementation activity. Incidentally, this is also our DFD level 1. Would you rather, describe all of these relationships between these modules in words, in a sentence, or with graphics? Well, think about your reader. Your reader probably wants to see this graphic too, because they're gonna, by the time they remember what the network utilities are, they're gonna have forgotten all about AR fragment or AR activity. But here they can easily switch back between different pieces of information, conceptualize their relationship, and then the more they actually know what these things are, the easier they'll be able to read this. Let's see, do we have that weird ES thing happening? Not here, okay. There are 6 major modules in this system. They are described in more details in section 6, but here's a brief overview of them. R fragment, or AR fragment, and AR activity. These are separate classes, but they act as one module, as the functionalities they provide are almost the same, and it comes down to whichever style the developer prefers. These components are specific to the Android interface or subsystem, and as such, they are provided only as a convenience for the user. Both of them automatically take care of setting up permissions, sensors, camera, and OpenGL rendering, so the user just has to implement what they would like. 3.22, AR view and AR camera view. Both of these, again, are the same, and they act as one module. These components are implemented by AR fragment or AR activity, respectively, to provide a camera view and an interface for the motion sensors. The user may choose to directly implement either of these views to create their own activity or fragment with a custom behavior that is more tailored toward their needs. This is an interface that abstracts the GPS sensor's functionalities. It is further abstracted by either the AR fragment or AR activity to provide data to the user without making them go through the trouble of setting up permissions for this. Interesting. Now, I don't really know what it means to abstract something in this context, but maybe you do. Maybe this section is not for me, but that's okay. Because it's in certain cases, it is the reader's fault for not really knowing enough. It's not up to the author to define every single thing. And it seems like they're actually trying to define things as best as they can, but they can't take me all the way back to CS 101 and walk me through this. So some of it's on me to look into, but I can still sense through the quality of their language and the thoroughness of their descriptions that they are discussing the particular relationships between softwares. And I can even kind of get some sense of what these softwares are doing. Makes me wish I was making computer programs right now, or knew how. AR motion sensor. This is yet another interface that abstracts the motion sensor's functionalities. It is further abstracted by either the AR view or AR camera view to provide data to the user without making them go through the trouble of having to set it up. 3.25, network utils. This is an interface that is specific to the app and is not part of the framework. This interface allows the user to make a connection to the internet without having to go through the procedures of having to set it up. It can be directly referenced by the user, but in this system, it is utilized by the service classes to provide data for the user. 3.26, the service classes, what are they? These are described in more detail in section 6.20, essentially. These are the various service classes that provide an interface to connect to the water truck database and retrieve hydrology data. All right, we're going to get to 3.3 implementation in just a second, but first, intermission. Welcome back from intermission, everybody. Let's get back to it. We are on 3.3 implementation. This project was split into 4 sections to allow for efficient development: water tree and hydrology data, local data management, user interface and experience, and the AR framework. Each section plays a key role in presenting the progression of the project. 3.3.1 Water trek and hydrology data. Hydrology data is gathered using JPL's REST API and the project's framework's backend. Overlaid digital elevation map data is loaded locally to indicate altitude. Each pixel in the raster layer of the DEM corresponds to a range of coordinates, and the visual representation of the pixel represents the elevation and altitude value. Interesting. 3.3.2 Local data management. Using an internet connection, raw data from JPL's server is stored in a long string and is parsed before being pushed into the local database. The data can then be pulled from the local database and be displayed. Data may be updated and overwritten when an internet connection is available. 3.3.3 User interface/user experience. A user interface was designed specifically for the project to visually present the framework. The UI allows for interaction with the functions of the framework without accessing its components or requiring any knowledge of how to use it. 3.3.4 AR framework. The framework contains 3 major components: user interface, sensors, and rendering system. The user interface provides a surface for displaying camera output with 3D graphics drawn on top. The sensors provide GPS coordinates, altitude, accelerometer, gyroscope, magnetic field gravity, and orientation of the device. The rendering system makes use of the drawables, entities, the camera, and the scene. All right. And part 4, conclusions. Before we get into conclusions, let's talk a little bit about what we learned. I think I'm starting to understand that they used these other aspects of what the camera could do, or what the phone could do, along with data, in order to create the images that would then be represented. I kind of want to see this thing at work now. This sounds really interesting. All right. 4.1 results. We have created a framework that allows rendering 3D objects, 2D objects, and text on top of a smartphone's camera output. This gives the appearance of the graphics/information existing in the real world. By taking the smartphone's location and orientation sensor data and forwarding it to the rendering system, the graphics adjust as the device is moved, thus maintaining them in the correct position. We have created classes and methods that allow easy access to many of JPL's water trek data. This is not only needed for the application we are producing, but can be used in apps from other developers. The database module of our app stores the downloaded data locally and allows efficient processing of the data as needed by the application. Finally, these parts have been brought together with an aesthetically pleasing and well-designed user interface to showcase the developing technology. To showcase the developed technology. They're done developing it. Not really sure what these artifacts are. Looks like somebody was supposed to come back to it maybe and fix it up. And you might feel like, what you are turning in is in a way incomplete. And, you can write something forever and never really feel like it's done. There are some elements of this There are still some subject-verb disagreements, for example. But what makes this a good example generally is that you can see that from what is here, everything was documented in such a way and presented in such a way as to be honest, accessible, and as clear as possible. They understand that you weren't with them when they came up with this project, and they do what they can to discuss what they have done and the applications for it. I'm going to take a look after we're done with this and see if I can find any more information about it, or maybe even a visualization of it or something on YouTube about it. Well, let's see. As discussed earlier in section 2.1, AR is not new. The techniques of using the GPS and sensors of the device along with the coordinates of real-world objects to properly render the AR objects have been used before as well. However, our project makes an important and significant contribution to AR by making these techniques available in a framework that can be quickly and easily adapted to many applications. There are many potential uses for this software related to learning, research, guided work, and entertainment. There is much still to do, and we're happy to know that this project will be carried forward by following design groups at California State University, Los Angeles, following our suggested improvements for the next year's team to work on. So this is interesting. Does it really add to the field of AR by having this data set that it's pulling from? Because when I think about it, yeah, maybe that's what's unique about it. Not that they're doing AR, but the way that the data interacts. I mean, I know with like Pokemon Go, there's not a lot of interaction. You do have to figure out what Pokemon you're looking at. The model for the Pokemon is already in your phone. I don't know. I would like to know more about how this works in a special way. But let's take a look at their suggested improvements for the next year's team to work on. Improvements to tracking of the device's location. Right now, location is accomplished strictly with the device's GPS sensors. This is a very coarse and sometimes unreliable reading. Improvements could be accomplished with filtering and combining GPS locations with accelerometer, gyroscope, sensor data, or by using computer vision techniques. Oh, okay. So is this kind of like when you look into the night sky and I mean those phone apps where you can look at the sky and it shows you where the stars are, but it's really just one of the sensors? I think there's gyroscope in that though. So maybe like what I was imagining isn't as cool as it was. Like I was imagining in my head, you look at a mountain with your phone and then the data would populate like where the water towers are on the mountain, or the water, not towers, but the water containers or whatever they are, where the water is on the mountain. But maybe it just tells you like not in context with the mountain. It just tells you based on which direction you're facing, where the different water features are or something. All right. Adding features to the rendering system. This could be accomplished by adding new rendering primitives or connecting the AR components of this framework with an existing rendering library. Okay. By the way, you notice it's very, I mean, what does it feel like when somebody's admitting like, we made it this far, but hopefully somebody in the future can take this to the next level and these are the steps they can take? What does that feel like? That feels like honesty. That feels like ethical behavior. You don't have to act like you actually solved all the world's problems. Just show what you did solve and what can be done based on your work. Add the ability to retrieve terrain elevation data from the network and generate a mesh from this data. This mesh could be rendered on top of the existing terrain to allow highlighting geological/hydrological features in the world. Even if it is not rendered or is transparent, this mesh could have other uses, such as allowing terrain features to be clickable or to prevent drawing objects that are not within line of sight. Creating general purpose components for use in the network and database subsystems. I don't know what that means. Expanding to other platforms. All right, and here are the references. What could they have done to make more clear what it was that they were making? Also, I don't really know why this is a problem. When I think about the fact that they're trying to solve it, I don't really know who wants to use augmented reality to find to access WaterTrek's database for hydrological features such as wells, reservoirs, rivers, etc. I suppose there is some interest that I would have as a random consumer or member of the public, but is there something I don't know about why I could use this information or who wants this information? When we think about the people who are already working in that field, they're probably working with maps. They may be directly working with the WaterTrek database itself. And so perhaps it's for them to find a much quicker access to the data. I wonder, I would like to see how well it works for members of that community, and if they would actually end up preferring it at some point to their traditional methods. But I do like how they were able to talk about what they were able to do, what they can be proud of. Like, yes, we made this thing where the AR data is based on this database that can change. When you see a lot of how AR is used, take out the Pokemon example, because I think that does have some geo features that might have come after this actually. But the way AR is often used is just like there's some pre-loaded content, like a dinosaur image or something like that, and all it's doing is finding a visual cue in your camera and sticking it to that visual cue. AR is good at obviously the visual cue doesn't have to stay exactly the same. It can actually turn, and as it turns, the dinosaur or whatever will turn. So it already had some strong visual features, but maybe it was lacking in the way that it interacted with data before. And now they're finding a way that, not only can you use our way of doing things to interact with this particular data set, but it could just interact with databases generally. So I think that's really neat. What do you think? Was there anything missing from this project that you wish that they had included just for your own interest? And in writing your own project report, ask, can I be as transparent as this? Can I speak to my field as well as this project does? And can I get somebody who doesn't really know that much about what's going on board with what I'm doing, while providing the technical details that people who are in my field would need to understand the depth of what I'm doing and the precision with which I did it. Additionally, there are these references. Let's take a look at them one more time. This group went with the link kind of references, which is increasingly popular. They might have needed some more references to tell them, but it does seem like also they did a lot of primary research, but I would have liked to have seen probably some documentation about what AR does in the field right now. And maybe that could have been like a consumer magazine or something even more tech-centric. like a trade magazine or something like that. And before we go, let's go ahead and look back at our concepts here. How did that document? I just noticed this weird tattoo this lady has. How did that document address its audience? Well, let's look at it one more time. The audience, remember, is people. You have to kind of imagine the audience a little bit better than your teacher who is grading you. The audience is the greater academic field around computer science, but also the professional field around computer science. These people in this team, the augmented reality for hydrology team, they realize that they're contributing to the field of AR. And it kind of shows, you know, they gave us background, but a lot of people do know about augmented reality, its technicalities, its limitations, but they still went ahead and they showed what they saw when they looked at the state of AR, which was down here. Wait, or was it existing solutions? They went, you know, they didn't just assume you all know what AR is. I don't have to tell you what the different AR platforms do and what they're good at and what they're not good at. They actually went back and they said, we considered all these platforms, and that's why we had to make a new platform for ourselves. Additionally, I think they know that people don't necessarily know that much about hydrology. I think they could have done a little bit more work in cluing in the reader about why they might be interested, why somebody would be interested in an AR program that would give hydrological features in an AR simulation. And maybe you felt the whole time like, why does this exist? And maybe in that sense, it could have been lacking a tiny bit in audience. What about the purpose? What was the purpose? The purpose was to show that they came into this field, learned about the current augmented reality platforms, and then were able to generate a new product that fulfilled its own goal. And it's not about the purpose of coming up with God's perfect program to answer all solutions, but the purpose of the document, which was to show what their contribution to the field was. Before we move on entirely from audience, I do want to mention one more thing. We also see that they thought about their audience when they created these graphics. They knew that to simply say all this stuff would be kind of confusing, really complicated, and they knew that the visual abilities of the audience to understand something visually like this would be great for something as complicated of a system as this. I don't even think it's probably that complicated to you guys. You guys probably know exactly what's going on, but to somebody else, they're like, "Ooh, what?" Another part, yeah, and they also recognize that even though they want to impress their audience, it's more important for them to be honest to their audience. And we'll talk back about that when we get to ethics. But back to purpose. The purpose was to demonstrate their contributions to the field in AR by showing how they created a system that would pull information from a database for the augmented reality simulation, while presenting its possibilities and its limitations. Remember, they didn't try to sell it like, this is done, download it now. They're like, we probably would tweak certain aspects of it and make it work a little bit better before it reaches potential. Honesty. So that's a big part of this one, is the honesty. I do sense it. They don't try to say this thing does something it can't do. Clarity. The clarity was there. They understood all of the features of the document, and they used it well. There were some grammar errors that confused me for a second, but I think there was enough editing done on this where it's very easy to parse what they were trying to say. Let's look at that logo one more time. Ta-da! Look, I don't know if you got a graphic designer in your group or not. Even without this great logo, though, we do see a lot of mainly, okay, let's look at a lot of things we take for granted in this essay. The font remained the same throughout. It's just Times New Roman. Oh, sorry, I guess it's Cambria. It's Cambria? Okay, it's Cambria. They fly now. And then you have every single time they introduce a new chapter, or what would you call these? I don't know, module or section, they got 20-point font, bold, consistently. And then we've got the 14-point font, bold, consistently. Probably don't need colons after everything, because if you have a colon after everything, we'll kind of start realizing that's a little redundant. We understand the relationship between a title and its content. So you probably didn't need that. But anyways, I overlooked it because everything looked good. They remembered to go back to this 12. Oh, okay. So this is 12 font, Times New Roman right here. And then these are Cambrias. I get it. All right. So these are Cambrias. This is Times New Roman. Or is it? Wow. I'm not really sure. Maybe it's not. Maybe there was a change. I didn't notice it because they did such a good job with the general impression of it. And also just choosing fonts that looked enough alike that I didn't notice a switch. I don't think they did that on purpose. And also it could be my computer not really keeping up to date with what I'm doing, because Cambria. Looks like up here Cambria does not have serifs, but here there are serifs. So that's what's tripping me out about this right now. Hang on a second. Cambria. Is that really Cambria? Okay, I don't know. It's blowing my mind right now. Okay, but moving on. That's the professional appearance. I think we can all agree it's got a professional appearance. People don't, a lot of times reference pages are a lot more elaborate than this, but this gets the job done. The links take you where they want you to see that they got the information that you're looking for. So I think it's okay. Anyways, going back to our other standards of excellence here. Usability. Well, what I was using it for was just to understand their process, and I saw their process. Other people might need to use it for something more specific, and if that's the case, you can tell me how usable those graphs are that they offered, how usable the future aspect of their project was, where they imagined what you could do in the future with their project. Maybe one of you is actually working on this project, and you can tell me, was that usable for you? Did it help you get on board with what they were doing. Accuracy. Hard for me to judge because I didn't go and check anything that they were saying, but I just believe that they're being accurate when they're talking about the current or the contemporary to when they were doing it, AR technologies and that sort of thing. Conciseness. Nothing felt too long. I think there could have been a little tiny bit more information at points, but I never did feel like anything was redundant about it, particularly. I didn't feel like things were wordy or overly so. There's probably moments where you could really compress the language more, and I'll take a look at that real quick, just for fun. Somebody has once said that almost all documents could be decreased by about 10 to 20%. That's something you wouldn't think you wanted to do in a class because you're like, oh, doesn't my teacher like things to be super long? Well, no, your teacher wants things to be well done. And sometimes when it comes to technical documentation, well done means concise and to the point. By visualizing, let's take a look. NASA's Jet Propulsion Laboratory, JPL, is world famous for their work in space exploration. Yeah. World famous as its own adjective could be that. You could probably take out the word world. You might not even need to tell us that they're world famous. That might actually be extra. If you really wanted to, you could probably just say, NASA's Jet Propulsion Laboratory does a lot of work in Earth science. One example is JPL's WaterTrek database. WaterTrek contains a vast amount of data and hydrological features such as wells, reservoirs, and rivers. Because it says such as, you kind of didn't need the etc. there, and rivers, but currently this data is readable only by scientists. By visualizing this data in a more meaningful such as, I think it's could just say a meaningful way, such as with augmented reality, and then probably should be like this in the right here. I'm doing too much right now because it's already pretty concise, and you might actually feel a little pain as you see these words go away. By visualizing this data in a meaningful way, such as with augmented reality, and you probably don't need this word techniques, this vast amount of information may become more approachable. Let's say become more approachable to the general public. So yeah, so I don't know why you would want this. So the therefore isn't really working for me. I would just say in this interest, I don't know, JPL has teamed up with the California State University of Los Angeles to develop an AR application to show, and then I would change this to showcasing WaterTrek data. In addition, a development framework will be provided for other developers to use. The framework is designed for general purpose AR, meaning that the same techniques and libraries can be applied to other scientific data, not limited to just hydrology. All right, so I barely could reduce that without losing a lot of meaning. You might already hate the changes I did make because it is concise, actually. That's not a problem with this one. Let's go back. Correctness. You'll have to ask somebody who knows. I believe them, just like I believed their accuracy, I believe their correctness here. And honesty. Once again, I thought that it was honest. They are honest with themselves about what their program can do, and they're honest with you about what their program can do and what you could do to build off of it if you have the skills necessary. They didn't, and I know there's going to be this temptation to maybe end your project with a grand statement. about how everybody should adopt this thing because you worked so hard on it. But instead, what if you're just honest and said, hey, next group who picks this up, this is what you can do to make this work. All right. You've got all this material. You might be able to take a lot of the quiz by just looking at the document itself, but some of my analysis is also going to be likely in the quiz. And you're going to have to understand this document at least as much as I understand it in order to take this quiz. All right, everybody. I'll see you next time. All right. So thank you, though, for sitting along through the reading of it with me. I hope that you got a feel for the flow of the format. If you have any questions, please email me at jadachi2@calstatela.edu. And I'll be seeing everybody soon, so I look forward to that. If you hate the music, go ahead and email me and tell. If you like the music that's playing, go ahead and email me and let me know. And I'll look forward to seeing you all soon. Take care.